Okay, so let's start by creating our own project. Now I'm going to do this in 4.11.2. As you can see, I have 4.12.5. I've had some issues getting Android to compile for 4.12. I think that might be more due to a third-party plugin that I purchased for creating advertisements in the game. But just to be safe, since I know 4.11.2 works, I'm going to stick to that. So what I'm showing you should work in 4.12. I just can't guarantee that it works in 4.12. So let's go ahead and start with that, and let's create a new project. Let's go ahead and launch this. Okay, so we're going to go ahead and click New Project. And let's just go ahead and do first-person shooter. And we'll set this to mobile tablet, maximum quality with starter kit. And so for the project name, and this is something that is very important, make sure that you don't have any dashes or underscores in your name, and I'll explain why in a minute. So we'll call this tutorial 3D motive. Now the reason why is because, as I found out the hard way, as you can see here, the name here is TLR underscore endless nightmare. When I went to build my game on the iOS, it created something called an XML scheme, and it used the name of the project as the XML scheme name, and the underscore was an invalid character. And it would compile just fine, but every time I went to upload it to iTunes Connect, it would fail because the scheme was invalid. Naming your project from the get-go is already important. It's already got a gotcha in there. What I had to do is on the Macintosh that I am renting from Mac and Cloud, let's get back to here real quick. I had to rename it and just simply take out the underscore. And then it worked just fine. So here's our thing. And we're going to run around. You see here the virtual console for the mobile here. We can disable that if we want or keep it. It doesn't matter. When you play it, you want to switch it to mobile preview. And this is going to more closely approximate what's happening on your mobile device. And see there's got the little like tablet icon or iPhone icon there, whatever you want to think about that as. And so right now it's crunching things down to be mobile compliant. That took a little bit, but there we go. And you see it's still compiling shaders, so everything kind of looks grungy. It's not going to look fantastic in the first place because it's all temp shaders, but you get the idea. Okay. So let's exit out of there. So a few things with mobile. Let's start by looking at textures. So with textures, basically you just want to use the default and normal map. It's recommended, or no compression at all. It's recommended that you stick to those formats because mobile devices rely heavily on OpenGL and not DirectX or anything else. So that's what's recommended. If you look at the actual materials, let's take a look at this one real quick. So this one's pretty basic. This one is good. Let's click on mobile stats. Just kind of make a change here. So now you can see, if you scroll down, mobile texture samples, 4 of 8, as opposed to texture samples up here, which is 3 of 16. So you have way fewer texture samples that you can pull off from. So your shaders are going to have to be more simple. See, and I only have 2 actual textures here. It's reading the other samples because this is being sampled twice. I'm still not sure why we're getting 5 of 8, but you get the idea. You have way fewer instructions to work with than you would if you were dealing with a PC version. If you look under shading model, it is set to default lit. Now you got unlit, default lit, subsurface, pre-integrated skin, clear coat, all this other kind of good stuff. Default lit and unlit are pretty much the two that you want to stick to. Most of these others are not even supported for mobile. Keep in mind, things change. Every time Unreal rolls out an update, they add more functionality. I believe 4.12 added a lot more support for translucent materials in mobile, for example, and better shadow casting. So things change, but as the time of this recording, you want to stick to unlit and default lit. So polygon count. Because you're on mobile devices, you want to keep your polygon count under about 500,000 per scene view. Now that's not for the level, that's just for what the camera is actually seeing. So for example, if you were, say, doing a VR thing, you're in the middle of the room, you had 5,000 to the left, you have 5,000 to the right. If there's no way to see both at the same time, you're fine. As long as you're not seeing more than 500,000 at any one given time. Now one way we can kind of test that, we can go stat engine. And so down here at the bottom we see on the counters we got scale mesh triangles, which is at 30,000. And then we have static mesh tribes, which is at 4,000. So that means we're running about 35,000 polys roughly. And you can see here that our static mesh tries are changing as we're running around. So this should give you a really good idea of what you're running. And if you use that command, that should help you to keep things down to below 500,000. Another limitation you're going to have is the number of joints per character. So as we can see here, this is actually a pretty full skeleton. Now this should be the Unreal Standard mannequin, which I used on my project, The Last Rite Endless Nightmare, because I wanted to basically make the process of getting a character running around as simple as possible. It was my first game done completely by myself in Unreal, so I wanted to kind of keep things as simple as possible. So I just used their character, their animations, added a few here and there, and then I was good. So joint count wise, this guy is just slightly under the limit. The skeleton bone count limit for mobile is 75 joints, and I believe he's around 72 if I remember right. So he's okay, but we're not going to be able to get much higher than this. We're not going to get like a full facial rig and all that kind of stuff and still have all this going on here. We've got to cut somewhere if we want to add to this. This is about the maximum that we're going to be able to get away with on mobile. Couple more joints, that's about it. If you exceed that limit, it's simply not going to show up. It won't render. And the last thing I want to mention briefly is scaling your UI across different mobile devices. And this is something that I'm not exactly an expert at, haven't really perfected it yet, but I did get it working, and I want to share with you the little bit that I am familiar with. So if you come here and look at the main menu, if you switch the screen size, you'll see here that this is your screen size for your basic cell phone, your Samsung Galaxy resolution. And you can see this is pretty much HD resolution. If you switch that to iPad, you see the proportions change pretty drastically. It is taller than it is wider. We've gone from a 16:9 ratio to a 4:3 ratio here. So there's two things that I had to do to make sure that this UI fit both iPad and Samsung Galaxy format. and hopefully every other format in between. Now, there's two things I had to do. First of all, if you switch this back to our HD dimensions here, our 16 by 9, and we click on this image, you'll see that this image is oversized quite a bit. Okay? The reason why is because there are rules that are in place for stretching the textures uniformly as the UI grows and shrinks. However, because the iPad is different dimensions, it's basically shrinking uniformly based on one axis, not both axes at the same time. So I oversized the image a bit, so when it's being stretched, and the display area increases, it doesn't clip. Now, the main mechanism for governing how the UI reconfigures itself and resets itself is going to be here under your project settings. Now, if you come down here to user interface, now down here we have the DPI scaling. Now, this curve basically represents how much this is going to scale based on the changes along the longest side. Now, by default, it's set for shortest side, but because my game is in landscape mode, in other words, the phone is tilted on its side, the longest side served as a better indicator as to how much I needed to scale. If you are doing your phone or tablet straight up and down, kind of like, say, Pokemon Go, then you might want to stick to shortest side. That might work better for you. But basically what this is saying is that in the changes of resolution, I guess somewhere around here it's going to be 1. Okay, so here's 1980, which is our HD width, or HD left and right. We want to scale to 1. So as the resolution changes, it's going to dictate how much it has to scale everything up. Now, as I said, it's doing it uniformly based on one axis. That didn't work when switching from Samsung Galaxy phone to iPad, which were my two main devices I was testing on, because of the difference in proportions. That's why I had to oversize the textures, as I mentioned before. But this works fairly well in scaling up and down the UI. So those are the main gotchas that I found in dealing with mobile. I had to keep the triangle count low. I had to keep the shaders simple. I had to go in and simplify a lot of predefined shaders that had come with Unreal because they're by default a little heavy for mobile, and in some cases wouldn't work or wouldn't work very efficiently. It would slow down things. I had to keep the polygon count as low as possible. I tried to keep things with as few shaders as possible because each shader is a draw call. The character, for example, was originally 3 separate shaders because I wanted the hair in one shader, the skin in one shader, and the cloth one shader. And then I realized that subsurface scattering and hair shaders don't work on mobile, so I wound up condensing everything down to a single shader. That took it from 3 draw calls down to 1. And of course we had to make sure that the shaders had as few texture calls and shader instructions as possible because you have about half of what you would on PC. So those were my main issues when dealing with mobile in getting things set up. The next issues I ran into was just getting things ready for Android, and we will cover that in the next chapter.